Hi, my name is Scott from the Economics Tutoring Center, and today we're going to be talking about the binomial distribution. Please remember to check all notation and language use with your instructor because it may vary. So our first question is, we want to know when to use the binomial distribution, and there are generally three things that you need to have when you're using it. You need a finite number of trials. This can be like a number of people who you're asking a question. You need a probability of successes and failures, and I put those in quotation marks because a success isn't necessarily good and a failure isn't always bad. It just basically means yes or no. It's like you're asking a yes or no question. And you need a discrete sample data, and discrete just means you can count the number of people or observations. It's a whole number. So for our notation, P will be the probability of a success, and N is our sample size. And from there we have a few details about the binomial distribution. The mean of the binomial distribution is the expected value. You take the sample size, multiply it by the probability of successes. The variance is another formula you need to know. You take the sample size times the probability of a success times 1 minus p, which is the same as the probability of a failure. And then this is our probability mass function, and you use this when you want to calculate the probability of a certain value in your data. So if x is that value that you want to find the probability for, then you use this formula here, n choose x times p to the power of x, 1 minus p to the power of n minus x. And remember that n choose x expands out to n factorial divided by n minus x factorial times x factorial. So that's what you use when you want to calculate the probability. And now we're going to do a few examples. So now we're going to look at two examples of using the binomial distribution. Our first question is, assume the probability that a student is a business major is 0.2. If you randomly ask 10 students what their major is, what is the probability that exactly 3 of them are business majors? So first we need to identify all of the parts of our formula. So 0.2 here, that's the probability of a success in this case. And again, success just means a yes answer to the question. We're asking 10 students, so that's our sample size, and we want the probability that exactly 3 of them are business majors. So in our formula, that will look like the probability that x equals 3 is 10 choose 3 times 0.2 to the power of 3, so that's p to the power of x, and then 1 minus p to the power of n minus x. And this 10 choose 3, not 10 divided by 3. So then if we calculate that, we have, first of all, we calculate 10 choose 3. You can either do that on your calculator or expand out into the factorials, and if you do plug that into your calculator, you'll get 120. So then our formula, the probability that x equals 3 is 120, and then we have p to the x, so 0.2 to the power of 3, and that gives us times 0.008, and then we have, over here we have 0.8 to the power of 7, and that gives us 0.21. So if we multiply all those together, we get the probability that x equals 3 is 0.2016. So that's the probability that exactly 3 out of 10 of these students are business majors, given that the probability that a student is a business major is 0.2. So our next question is, assume the probability of a coin landing on heads is 0.5. If we flip that coin 8 times, what is the probability that it comes up heads 5 times or more? So the key difference in this question is this or more part. And one way we could do that is we could calculate the probability that x equals 5 all the way to and 6 and 7, and the probability that x equals 8. But this would take a while, and if you have a bigger sample size especially, this could take a very long time. So usually this is not the way you want to go about it. Instead, what we can do is, if you have a graphing calculator or Microsoft Excel handy, you can use the cumulative distribution function. So on a TI-83 graphing calculator, you press second, go to distribution, and then you scroll down, choose binomial CDF, and you type in n, your sample size, p, the probability of a success, and then a certain x value, and this tells you the probability that your data is less than or equal to that x value. So what we can do is we can calculate the probability that x is less than or equal to 4, and then if we subtract that from 1, that gives us the probability that x is greater than or equal to 5, because remember, this is discrete data. It has to be a whole number. So how we do that, we go to, on our graphing calculator, second, distribution, and then we have the binomial CDF. We type in our sample size, we're flipping the coin 8 times, and then the probability that it lands on head is 0.5, and then we're interested that x is less than or equal to 4, so we put in 4 for our x value, and that gives us 0.637 on the calculator. So that's the probability, again, that x is less than or equal to 4. And then if we want to find the probability that x is greater than or equal to 5, we do 1 minus 0.637, and that gives us 0.363. So those are 2 examples of using the binomial distribution with calculations, and I hope it helped. So that's all we have today on the binomial distribution. I hope it helped, and if you have any further questions, feel free to come into the tutoring center or ask your instructor.